We have made the observation that we can add and subtract vectors and multiply them by scalars. We've also made the observation that although we don't tend to think of them in these terms, a vector is just a special kind of matrix. It therefore shouldn't be too surprising when I tell you that we can add and subtract matrices and multiply them by scalars. Just as with vectors, we do have the condition that these matrices need to be the same size. Just as with vectors, addition and subtraction is done component-wise. So for example, if we wanted to add these matrices, we could. They are the same size. They're both 2 by 3. And the first row, first column, plus the first row, first column. The first row, second column, plus the first row, second column. And so on. 3 plus 6, 4 plus 0. 0 plus 2, 6 plus 4. Subtraction is done in the same way. As for scalar multiplication, it's done in the natural way. Instead of multiplying every element of a vector by the scalar, we're multiplying every element of a matrix by a scalar. But otherwise, it's the same scalar multiplication that you've come to know and love. And just as with vector addition and scalar multiplication, this matrix addition and scalar multiplication has the properties you would perhaps expect multiplication and addition to have. In fact, if you go back to section 1.3 and compare, you'll see that this list of properties that matrix addition and matrix scalar multiplication have is exactly the same as the list of properties that vector addition and vector scalar multiplication have. And again, rather than thinking of this as an intimidating list of things to memorize, you should focus on the take-home message, which is that this addition and multiplication act in the way you are used to addition and multiplication acting.